Okay, everybody. So we'll continue on the urinary system.
Yeah.
It's interesting, right? Like it?
Yeah.
Okay. So you remember in last class I mentioned that there are three processes of urine formation: glomerular filtration, tubular reabsorption, and tubular secretion. So those are three processes. Glomerular filtration, tubular reabsorption, and tubular secretion.
We learned this last class, you said?
That's the last slide of.
We didn't get to do the last
We didn't
one.
finish the,
That was the last thing we had to
Yeah,
do.
that was the last one.
okay.
So that's why I'm writing it. Those are three processes of urine formation. Okay. So what are those three processes? You remember the nephron, which is the functional unit of the kidney, and the nephron looks like this. And the capillary ball, tuft of capillary, which is called the glomerulus. We talked about that, right, in last class. Like this, a ball of capillary. And this is afferent arterial, this is efferent arterial, and in between you have the capillary, a tuft of capillary, right? That is called the glomerulus. So this is the glomerulus. Okay? And this part is called Bowman's capsule. Capsule. Okay, and these two structures together is called renal corpuscle. So those two things, that means the glomerulus and the Bowman's capsule together is called renal corpuscle. Okay? It is like this. See, this is the glomerulus, the ball of capillary, and this is the Bowman's capsule. Okay? Together is the, so it's like a cup that is partially covering, not the whole thing, like partially covering the glomerulus. Okay? Now, you remember I said that this capillary is fenestrated capillary, right? So the fluid can easily get out and enter into the nephron. And that process is called filtration. So this is the process by which the fluid from the blood enters into the nephron. So that is called glomerular filtration. That's the first process of urine formation. So that happens first. Then the fluid starts to move, okay, through the nephron. How much fluid enters into the nephron? in 1 minute in 2 kidneys together. 2 kidneys means how many nephrons? Anybody?
Oh.
Each kidney has about 1 million, right? So 2 kidneys have about 2 million nephrons, right? All together, how much filtration occurs in 2 kidneys? That in 1 minute, that is called glomerular filtration rate. In 1 minute, how much filtration occurs? Make sense? In 2 kidneys. That means in about 200 million of nephrons. So that is the glomerular filtration rate, or GFR, which is about 125 milliliter per minute. So in 1 minute, in 2 kidneys, this amount of filtration occurs. And then the fluid starts to move through the nephron. And when the fluid is passing through the nephron, at different locations, what happens? Some water and other chemicals are taken back into the body. That means taken out from the nephron. And remember, this is important to know that when I say going out from the nephron, the tube, that means it is going back into your body. This is very important, okay? Anything, just remember, that is getting out from the tube, that means will stay in the body, okay? Will go back to the body. Anything that will remain, this is also important at the same time, anything that will remain inside the tube will get out as urine. Is it clear? So, this is going back to the body, and this process is called reabsorption. Tubular reabsorption. That means your body is getting back water and other chemicals. That process is called what? Reabsorption. Is it clear? When I will mention reabsorption, that means it is staying in the body. Okay? And also, at the same time, another process takes place that is called secretion. It is just opposite of reabsorption. That means from the body directly going into the tube. That is called what? Secretion. So now you see that these are 3 processes: glomerular filtration, tubular reabsorption, and tubular secretion. And reabsorption and secretion are just what? Opposite. Is it clear? And I said reabsorption means
Gets back to the
gets
body.
back to the body. Okay? And secretion, anything secretion will occur, will get out from the body with the urine. That is important. Okay? So all those 3 processes,
That's the 3
Okay.
processes of what?
urine formation. Okay? And finally, this is the collecting duct. You remember that? The water and the chemicals that will stay here will get out as urine. So after reabsorption and secretion, whatever remains here gets out as urine. Make sense? So that's how the urine is formed. Now, if 100 milliliter of filtration is here at the beginning of the nephron, 100 milliliter of fluid is here, when finally it gets out, the volume becomes very small, only 1 milliliter.
Whoa.
That means what? 99% is taken back into the body. Make sense? 99% is taken back into the body. And how much is getting out as urine? Only 1%. Okay, so now we'll see the reabsorption. Which chemicals are reabsorbed in the nephron? About 65% of everything is reabsorbed in the proximal convoluted tubule. This part is called the, you already know, we have talked about different parts of the nephron. So this part is proximal convoluted tubule. So a lot of fluid gets back into the body in this part, in the proximal convoluted tubule. Okay. We'll get back here. So it's the glomerular filtration rate is, I said 125, so it's 120 to 25. Yeah. In proximal convoluted tubule, about 65% of water and other chemicals, that means everything gets back into the body. Now everybody tell me, if the volume is 100 here, how much will be reabsorbed when it passes through the proximal convoluted tubule? 65 milliliter, makes sense? So how much will remain here? 35, makes sense? So only 35% remains here, right? The 65% is reabsorbed. Okay, good. And now another thing you need to understand is, this is a container of solution, fluid, and you have water and glucose. Okay? So this is glucose solution. Now you tell me, if I take the water only out from here, the concentration will go up or down?
Down.
If I take the water out, up. You all know that, right? Okay, good. If I add water here, concentration will go down, right? Okay. Now, if I take the glucose out, only glucose, not water. I take the glucose out from here, the concentration will go down. Make sense? Okay, so this is very important for you to know, okay, to understand what is happening here. Now you tell me, if I take water and glucose both out simultaneously and proportionately, then the volume will go down, right? But the concentration will remain same because I am taking both of them out, right?
Right.
So glucose as well as water. Okay. So now here you see I said that everything gets out 65%. That means both water and solids. Make sense? So the volume will go down a lot, but the concentration will remain same. Make sense? Because I am taking both water and solids out. Okay? So everything will be reabsorbed here. It's not selective. Okay, so the volume goes down to 35%, but the concentration remains what? Same. Is it clear? Okay, now when the fluid will go down through the descending loop of Henle, what will happen here? This part of nephron will only let the water out. The solutes will remain inside. It's only, it only allows the water get out. Is it clear? So now you tell me, if only water gets out inside the tube, the fluid concentration will go up. Make sense? That's what I explained here. You take only water out, concentration will go up. Okay? So the volume will go down. So as you go downwards through the descending limb of loop of Henle, the concentration increases. Since only water is getting out, volume goes down further. Okay? And when it arrives here, the fluid, the concentration is very high. Concentration is what?
High.
Very high, because all through, right, water was taken out. Here, the concentration in proximal convoluted tubule is 100 to 300 milliosmol. MSOM, milliosmol is the unit, okay, of osmolarity or concentration. You can say concentration. Okay, so here the fluid concentration is 100 to 300 milliosmol. And when it arrives here, the bottom of the loop of Henle, long loop, it is about 1200 to 1400 milliosmol. So very high concentration here, right? The bottom of the loop of Henle becomes highly concentrated. Now you see what happens in ascending limb. Now the fluid will go upwards through the ascending limb of loop of Henle, and this part, interestingly, will not let the water get out, but will let the sodium, chloride and potassium out. Okay? Sodium, chloride and potassium. So just opposite. This part allows the water get out. This part doesn't allow the water get out, but allows the solutes get out, right? So now you tell me, as the fluid is going up, sodium, potassium, chloride, those electrolytes or solutes are getting out, but water is remaining, right? So what will happen? The concentration will go. If you take the solute out, down. Make sense? So, because water is staying there, you are only taking the solute out. Make sense? So, the concentration as it goes up, the concentration decreases. Make sense? And when it arrives here, as the concentration is going down, 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 when it arrives here, it becomes almost same concentration of here, the same level. Okay? So this is interesting. You see, concentration is going high, very high, and then concentration is going down again. But the net result is we are as the fluid is passing through the nephron, the volume is always going down, right? By reabsorption. So, now this part, this is the distal convoluted tubule. What happens here? Hormone name aldosterone aldosterone is an adrenal hormone, adrenal gland hormone. You must remember the adrenal gland sitting on the kidneys, remember? Suprarenal or adrenal gland. This hormone comes from the adrenal gland and works on the distal convoluted tube. And what it does? It helps reabsorption of sodium. Reabsorption of sodium. If this hormone is more sodium will be reabsorbed. Make sense? If this hormone is not present, no reabsorption of sodium will occur. So this hormone is causing the reabsorption of what? Sodium. Okay? So sodium is going back to the body. And remember, sodium always tries to take water out with it. This is a property of sodium. Sodium binds with water and takes the water also out with it. So sodium plus water will get out, will be reabsorbed in presence of aldosterone. And in exchange of that, potassium will get in. Potassium ion will get in. So sodium will get out. In exchange of that, potassium will get out. Sorry, sodium will get out, potassium will get in. So reabsorption of sodium and secretion of potassium. You remember I said secretion means getting in to the tube, right? Reabsorption is getting out, secretion is opposite, getting in. So that happens when one sodium gets out, one potassium gets in. So that is the function of aldosterone, and it works on which part? Distal convoluted tube. Okay. Now let's see what happens here in the collecting duct. This is the collecting duct, the last part, and this part is highly sensitive to a hormone, pituitary hormone. That hormone is called ADH, anti-diuretic hormone. Comes from posterior pituitary. You remember pituitary gland? Anterior, posterior, right? So from posterior, oxytocin and ADH. So this ADH comes from your pituitary gland in your brain and works on this part of the and it does what? Causes water reabsorption in the collecting duct. Reabsorption of water. Okay, makes sense? Now you tell me, if ADH is secreted more, it will work more on the collecting duct, right? That means it will do what? Reabsorb water more. Makes sense, right? If more ADH, more water will be reabsorbed from the collecting duct. Reabsorption means what?
Stay in the body.
Staying in the body, very good. Taken back, right? Taken back into the body. So now you tell me, if more ADH is released from your pituitary gland, more water will be taken back into the body. Will stay. Is it clear? So blood volume will go up or down? Up. If water, if water gets out from the body, blood volume will go
Down.
down. Make sense? Now if blood volume goes up, the blood pressure will go up or down?
Up.
Up, right? Make sense? So you see, more ADH means the volume of blood will increase. Blood pressure will increase, right? And now, if opposite happens, you got pituitary tumor or stroke, pituitary gland, posterior pituitary has been destroyed. Okay, So ADH production will not occur. Make sense? What will happen then? Reabsorption of water will not occur here, right? So water will stay inside the collecting duct and will get out as with the urine. Make sense? So that patient, that person will pee a lot, right? A lot of water will get out from the body. Make sense? So that clinical condition is called diabetes insipidus. Diabetes insipidus is a clinical condition in which the patient produces a lot of urine. Urinary output increases a lot. Okay?
So they don't make ADH.
Right. And that usually happens due to tumor of the posterior pituitary. So ADH production will be less or no ADH. That will cause frequent urination and large volume of urination. Make sense? So now you tell me, if that happens, the patient's body water amount will go down, right? Dehydration, right? And other complications. Blood pressure will go down, right?
So it's diabetes type 1?
No, this is a totally different type of diabetes. It is not 1 or 2. So it is not related to sugar. It is not related to insulin. Okay? It is totally different. It's not diabetes mellitus. Diabetes mellitus is related to pancreas, insulin, blood sugar. Okay? That's the difference. This is related to posterior pituitary and ADH. Has nothing related to sugar or insulin. Okay. And the other type that is insulin related, that is the diabetes mellitus. Okay. So that's what happens in this part. Now you tell me, if I see the whole nephron, I can divide into 2 parts here. This is the first part, this is the last part. Make sense? And which part is sensitive to hormones?
The last part.
Last part, right? No hormone works here. This reabsorption will occur by itself in almost same amount because no regulation, no hormonal regulation. But which part is variable part? This part, right? If more hormone, more reabsorption. If less hormone, less reabsorption, right? So this part changes a lot. Make sense? Depending on how much hormone is being released. And this part is kind of what? Fixed. This part is constant part. This is the variable part. Okay. Now you tell me another condition. You didn't drink water for a couple of days. Your body is dehydrated, right? So pituitary should release more ADH or not? More ADH should be released to
Keep the water.
keep the water. Make sense? Think very simple, okay? So to keep the water, reabsorption keeps the water, right? Keeps the things in the body, takes back. So if you don't drink water, your body water is less, right? That is simple. So your ADH should be released more to preserve the water, not let it get. Is it clear? Okay. Anti-diuretic hormone, its name is telling you. First tell me if you have heard the term diuretics. How many of you have heard diuretics? Okay. Sometimes newspaper, right? In the magazine you will see diuretics. So diuretics do what? Produce more urine. Make sense? Diuretics produce more urine. So anti-diuretics will do what? Less anti, right? Opposite. So we all know that diuretics are the chemicals or food that produces more urine. So antidiuretic hormone will produce less urine. Just think that one will make it easy. Okay. Now, if you drink a lot, like you have taken, 5 bottles of water today, so your body water amount is high. Make sense? So, ADH should be released more or less? Less, to let the water get out. Now you have a lot in the body. Now if ADH is released more, then more water will be reabsorbed. Make sense? So that's the function of antidiuretic hormone here. Okay. The 2 hormones work in 2 different parts. Aldosterone here, and this part is sensitive to antidiuretic. Now you see that in each kidney you have about 1 million of nephrons, right? So nephrons are so tiny, and within that small tiny nephron, particular part is sensitive to particular hormone. Make sense? So how beautiful, how beautifully everything is planned. It's amazing that that nephron is even difficult to see, right? With naked eye, each segment, right, sensitive to different things. Anyway, so that's how